7:41 on the clock. Do we want to start?
Yeah, let's start JavaScript in here.
Let's do it.
Yeah, and it looks like Partha has joined.
Oh, yeah.
Yeah. Hi there.
How's it
Hello,
going?
Partha.
Yeah. Hi.
All right.
So, are you a developer, Partha? Are you learning about
I'm
development?
actually a developer, but I do work in. I used to be a developer once upon a time.
Oh, cool.
Then my line of work changed. I'm doing project management, managing a team of enterprise quality assurance members right now. It's been a long time. I just doing it as a hobby, keep myself updated. That's all.
All right.
Cool. Yeah, it's probably good, especially for this week. Is a lot of kind of theoretical stuff, I think.
Yeah, I actually went over this. I think Sarah had another session going on, so it was part of that as well. Doing it, then we stopped it there. I took a vacation.
Oh, yeah.
Everything, I'm going to start again.
Nice.
Yeah, I went to a couple of the, or I joined a few of those that Sarah was hosting. Yeah, they were really good. Actually, I remember you had some really good insight. Oops. All right, so I'm just going to present to everyone and just kind of show the chapter and go through it. We can kind of comment on things. Obviously, you know, we're talking about higher order functions, and to me, I think what kind of solidified what a higher function is just a function that takes as one of its parameters another function, and then does something or doesn't do something.
I've also heard it described as a function that will define another function within it, or
Yeah,
even return a function. Yeah.
Somewhere in here he gives a definition that it's either a function that can take another function as an argument, or it returns a function.
Yeah, that's a good addition. Yeah. Which I think is the second. We get one of those examples pretty soon. Yeah, like here, we're returning another function.
Yeah, right. Yeah, right there. Yeah, takes an argument and returns a function.
Mm-hmm.
Yeah.
This is also kind of a way to actually get direct access to these inner values that you would normally not have access to. Just by calling the function.
Oh yeah. Oh.
Yeah. That's a good definition. Higher order. Yeah, of course, you know, going through these, I'm like, yeah, like I use for each all the time. Like I'm pretty good with the map. And then I got to the reduce, and I was like, I get reduce, and I was reading the description again, and I was like, I don't get reduce.
Right.
Okay, yep, reduce will do more than I thought it would on first glance, because, you know, I mean, I looked at it and I'm going, okay, yeah, returns a single value, you know, like, you know, I was thinking, you know, just a scalar, but you could make it return anything. You could have it return an object or another array, or, you know, it's something really complex.
Yeah. I've actually seen some pretty cool exercises where people have taken the reduce and then implemented other types of higher order functions using reduce.
Wow.
So you can write a filter function using reduce. You can write a map using reduce. You can write a reduce. You can write a reduce write with reduce. Yeah, that's a really cool article. I think it's called Reduce in Supreme. Try this one, because this guy is he does a lot of theoretical stuff, but yeah, he kind of goes through here and does exactly that. Like this is a for each. We're just taking a function and applying it to every member of the array, and then yeah.
Pretty
Same with
cool there,
math.
yeah.
Yeah.
I think reduce is an implementation of for each, but I think he's just showing how absolutely powerful reduce is. Yeah, it does a lot.
Yeah. It's very cool, especially like filter. Yeah, this is a really neat article. I will also share this one if you want.
Yeah, that's it. Yeah, there you go. Nice.
Yeah. So we may want to look at. Yeah, I really do like this idea, and I haven't spent a whole lot of time. I mean, I don't come from a math background, and I haven't spent a lot of time with like kind of functional concepts, but it it seems like it jives really well with kind of my aesthetic, I guess, as far as like I much more enjoy reading code that seems that reads functionally and like uses functions that are named well, and you can kind of read them like a sentence. Because
Absolutely.
who wants to look at this, really? Who wants to look at that? It works. And I understand it's faster, but he makes a point towards the end that I think is really true, that like the JavaScript engine now is so fast that we don't really have to worry as much about implementation details.
Yeah.
Like those functions are so highly optimized that if you're dealing with unless you're dealing with really kind of beyond normal scale data that you would use for a web page, you kind of don't have to worry about it, and you're more or less safe with using the more kind of declarative functional style. But if you did have to like optimize something, or if you're on a team where you're like, I could see at like a Google or somewhere being on a team where I'm just in a meeting talking about one function and how it operates, and having the debate of, do we use a for loop here, or what kind of big O notation is this?
Mhm.
I haven't had the pleasure of having that argument yet. One of these days. So yeah. Yeah, we just have some really cool examples here of you just using that for each function and just modifying it a little bit, and then we have these pretty common names for different kinds of functions that we run into a whole lot. So I really like this idea, and I think it's a good way of to me, the more I look at it, it makes a lot more sense, like what a for each does.
Yeah, I like that too. That he actually, instead of just using the built-ins, he actually wrote the code to show,
Mm-hmm.
here's what a for each would look like internally, or a map function. Or
Yeah.
Absolutely.
Do we ever have? Has anyone looked at the official specification on some of these?
Like the Mozilla
Nope.
Foundation?
Yeah. Oh, sorry. Oh, hey, Rochelle. Rochelle's here.
I haven't looked at it other than just how to use it. I just read through it enough to, like, I looked through it to find out there's a bunch of arguments that you can give to a reduce, and I read through that sort of stuff, but nothing about how it's really implemented internally.
Mm-hmm. Yeah, actually, so usually, like if you go to the MDM docs, it'll link to the actual specification, and then sometimes there will be a link to the file that has like the official implementation of it. That's not. I don't think I can get there from here, and I don't have it pulled up right now, but it's neat to look over. What's up? Yeah, I might look that up later. Okay. So let's get into one of these a little more is going on. So remember last time the werebear that we spent a lot of time on?
Well,
Yeah.
I think it was a were squirrel.
Oh, the were.
Yeah, that's right.
It was
Yeah, we're a squirrel.
way less intimidating than
Yeah,
a bear.
the werebear, that would have been a lot more damage.
Yeah.
That's right. Yeah, you wouldn't want to wake up in a tree as a bear. That was part of it. Yeah, I mean, this is that kind of, really kind of stereotypical example of like, this is very, very performant code that the machine really likes this stuff, but like we as humans, I find this difficult to just read through and understand what's going on. Like I can point to parts of it, but it kind of doesn't flow in a sense. Whereas if we kind of abstract away some of these for loops and use our implementation here, I mean, just the readability of this really becomes a lot easier, I think. Table 4. And this is probably, I mean, this is about as abstracted, I think, as you would want to get. You could probably take some parts of this and write another function.
Yeah.
Like this could probably be a filter. But yeah, I mean, this is pretty good code here.
Yes.
So in addition to this, this is kind of off topic, but what's been the best help to you, like to learn about kind of data manipulation or higher order functions?
Well, speaking of the code, I think that's one of the good things about this book is trying to analyze his code. Because it's complex enough, that you have to put some work into it to understand, and it's well written, and and illustrates the points very well.
Yeah. The only thing I thought was kind of missing was, and just reading it a couple times, it starts to make more sense to me. But I think the kind of process of the difference between them, like the difference between a filter and the difference between a map, and where it was. Let me try to actually find an example of this. And maybe.
Hey Dan, real quick, we had a question on the chat.
Yeah.
Asking, does a for each is it equatable to 2 nested for loops? So if we can just go back to the for each function that we were talking about.
The first one.
Did that make sense?
Yeah.
Okay.
So it's really just a single for loop, and what it's doing is taking an array and going through the array and performing this callback function. So the second parameter of a for each is a function. So this is that whole idea of the higher order function here, is where we're taking as a parameter a function and then passing it, actually using it inside of here. Here this is a for, but because typically in these kind of functions, the lowest level that I know of, at least, to get down to, is a for loop. So we're taking this callback function and calling it on each item in the array, that's what this for loop's doing. So you think of a for each as taking a list of things and a function and applying that function to each of the things, which can be one or more.
All right, you're good. Another thing about the for each, if you're new to it, is that it actually is a method on an array, so it doesn't take an array as an object. You would go array.forEach, pass it a function. Anyway, we're good. Sorry to interrupt the thing before.
Oh, no worries. No, thanks for catching that.
Yeah.
Oh, no worries, Vishal. Cool. That'll be cool if you get it fixed. Let's see. So I kind of did a Google search for this, but I couldn't find just like an illustration of kind of the correlation between the function, like that kind of talk, like what's happening here, like in that for each, how there's kind of this connection, between like parameter and operation, and I guess it would help. And maybe I need to make this, because I haven't seen it, make some kind of visual of that, kind of like going through and having it applied to each thing, and kind of on like have you seen those, like they're called like railroad diagrams? Actually, maybe that's a good thing to search. Syntax diagram. Not finding anything right away. But it'd be really cool to see that at some point. I'm sure it exists if anyone finds one. So just talking about like kind of illustrating the steps that are going on there.
Gotcha.
We'll get to a better example, and I'll bring that back up and try to illustrate it a little more. Okay, so we got our for each, and then like Alexa said, this is one of our. So I think we decided last time that those global, that these primitives, and it's, even that, I don't know if primitive is probably not the correct word, but these built-in functions that are part of the core library are attached to those global objects. So like we have the array, which is a valid thing here, and I can actually let's do this. Or you know what? I don't even need to do that. I'll just bring up the console. So like, array is a predefined thing in JavaScript. And array, you can actually just, like here in Chrome DevTools, you can just type array and then do dot and look at all the properties it has. So like it has apply, arguments, bind, call, caller, constructor, things to check for properties, things to ask another object if it's an array or not, check inside of, or check if something has a certain prototype, length, name of, these are all built in. And so on the prototype here, I have these built-in functions. You know, this this like blew my mind when I first found this. So you know, I got a concat. There's my filter, find for each. So I have this function here that's actually built into the language. So I could write my own for each like he does in the book here, or I could just use this built-in one. Actually, get it to print out the function. Can I do that? Is there a way to do that?
Did you? I don't know. Can you console.log it? That's pretty. Oh yeah, try just for each without the invocation.
Native code. I guess that's where it stops.
Can you console.log the array.prototype that for each? Drop all that in a console log. I don't know. This is pretty cool.
Yeah.
I never done this before.
That doesn't work either.
Oh.
Dang it. Well, anyway, so yeah, we got all these properties on the global object. I think that's what it says in the docs. So like array is a global, object is a global, and really like most of these things. He doesn't talk about this specifically in this chapter, but I've heard the case made before, and I think it's true that with just a few of these functions, you can either implement another function or accomplish whatever kind of data transformation task that you're trying to do. So a lot of these are just kind of like simple convenience things that you end up hyping a lot, so we built our own function. Or you know, it's built into the language, but typically it's implementing some other function under the hood. And then ultimately some type of for loop, so usually you can rewrite these. Yeah, understood. Anyway, I wish that would actually print the code. That would be cool.
Yeah. I think he probably does exactly what he put down here. Except for it would have this instead of the word array. Something like that. Yeah.
Yeah, I think so. Yeah, and there were, you know, usually the actual library implementation has things like null checks.
Oh.
And it has different kind of like edge cases that it'll kind of check for, or you know, it'll have like error checking built in. But this is kind of like the minimum viable implementation. The for each, which is cool. Yeah, just going through the array and then taking this callback function and applying it to each item by incrementing, and it's just, you know, using the incrementation method right here. And I wish I spent more time studying this chapter. I don't want to drag on too much.
I think we're good. That was pretty cool implementation. I didn't think to ever use the console to find out what functions I can use.
Yeah, and because
cool.
It'll often be different from browser to browser.
Oh, that's true too. Wow.
So some things will have like like this here. Oh yeah, this is it. Okay, so this is the actual implementation of reduce as a polyfill. So what this function does is it runs and it checks if this reduce function already exists on the array prototype, and if not, then it defines it, which is just a function. All it is a function that takes a callback. Yeah, which is kind of cool. And then it's doing like this bit shifting thing. So that's a lot faster. Oh boy. Yeah, but this is that null check that I was talking about, and it'll like it'll throw this error here if you try to give it a null value. and then it like checks if it's a function. And then this. I guess that's length. I don't actually know what this is right here. Is that a bitwise operator?
I have zero idea. I'm wondering what len is. Len. Is that defined?
This is a new. So that's just a new variable for length, and then whatever this is. So this is just a list of new variables here. Temporary, but yeah, I don't know what that is.
That's bit shifting.
Is it bit shifting, Danielle?
Sorry, my connection is really, really spotty. That's why I've been so quiet tonight.
Oh. Sorry, I'll shut up.
Well, no, I'm not really saying anything. That is.
Look.
Get to an answer.
Dang.
Okay, so I just found this Stack Overflow. What is this triple greater than in JavaScript, and what is it used for?
It says it doesn't just convert non-numbers to number, it converts them to numbers that can be expressed as 32-bit
Oh, okay. Unsigned right shift assignment.
Cool. All right. This is the real deal right here.
Oh, okay. I say okay as if I get it, but I only slightly. Ugh, memory addresses.
It's okay. It's something that I wouldn't have understood even if he'd explained it to me.
Okay. There's a difference in shift operators because you can either shift in ones or you can shift in. You know, if you're right shifting, you've got to bring in a new bit on the left, right? So if it's unsigned, you would want to shift in a 0.
Right. I think that's what that code does, doesn't it?
Yeah.
What,
yeah,
okay,
as far as this.
Yeah.
This right here. Yeah.
Oh.
From 0. Well, let's see what it does. Actually, I'm just gonna shift a couple numbers and see what happens. Go 0. I don't get it. I must be checking it.
Yeah, go back to the
Moves the specified amount of bits to the right, and it's specifying 0.
Number, for instance, and see what it does.
Oh, sorry, I just caught the tail end of that, Danielle.
Oh, okay, I was saying those can already be represented as 32-bit unsigned integers. To show something non-trivial, you'd have to do something that isn't already represented that way, like a negative number or a number so large it can't be represented in 32-bit.
Oh, okay. So. Oops. Oh, interesting. So, in any kind of decimal, probably?
Yeah, well, just anything that is not already represented as a 32-bit integer. So, like
Okay.
Or it's numbers that aren't integers. Presumably numbers that are larger than 2 to the 31st minus 1 or whatever it is. what have you. Well, unsigned, it would go all the way to 2 to the 32nd.
And it seems like JavaScript will actually, yeah, it'll convert it. Is she talking? I'm sorry. Okay. Yeah, JavaScript will coerce it into an integer, like she said, I think.
Yes.
And as you've demonstrated.
Yeah, that's kind of that beauty of. I'm starting to like that more and more about JavaScript. I think coercion isn't necessarily bad, just because it seems like there's stuff going on that you wouldn't be aware of. It's just kind of more stuff to learn the behavior of it, and then you can kind of take advantage of it, or use it for great power.
I think it's something that you have to be aware of. Like, if you're doing something that's really strict, that like types and stuff, it's really important that it's what it says it is, then job. So.
Hmm.
I'm just trying to do this example here.
Yeah, I mean, look what it does with the negative number. I mean, like when it's when it's equal to 5, positive 5, then it does what you would expect. It just shifts it. It shifts it 2 places to the right. But then when it's minus 5, it changes it all up.
Yeah. What's the largest possible 32-bit signed int?
Well, if we're dealing with unsigned integers, then it's 2 to the 32nd.
Okay. So that's where you're actually can be getting errors from not being able to calculate, or
Yeah.
Yeah. Oh. So how do you learn this stuff? What is this?
Yeah.
I've seen this one.
Yeah, I'm trying to think back, and I don't really know how JavaScript, represents signed numbers internally, but usually it's like in a 2's complement, where the binary representation of a positive number is just like what you think it would be, but then for a negative number, you use its 2's complement representation, and you end up with a sign bit on the left-hand side of that binary number, and it's a 1. Anything that's got a 1 in the leftmost digit is a negative number.
Oh, I didn't know that.
Yeah, and I can't remember exactly how you do the conversion to a 2's complement. Or even if JavaScript uses that representation, but that's a common way to do it in binary.
Yeah. Do we have operations for taking like a binary string and converting to int, or converting to?
I think I've seen something like that.
Like a.
I'm not sure if it was JavaScript, to be completely honest.
Converting to decimal. Yes.
Well, isn't there an identifier you can put at the front of a number to show whether it's hex or decimal or binary?
I'm not sure to answer that question, but apparently there's a function called parseInt. So number.parseInt, but the number is actually a. Not bad. I'm kidding. It's a just parseInt, and it takes the binary string and then the.
Oh, that's on string, right? So.
Yeah. Oh, so maybe that's completely wrong.
Oh. It's just parseInt. Okay, that's just a native function.
I think you're on the right track, though. There is a way to take a string and parse it as a number and tell it what base you're working in.
So I think I can actually, yeah, so this has an optional radix param also, where I can,
Yeah.
yeah, okay.
Yeah, there you go.
So if it's 1, 32. Oops. Okay. Oh, we got some more. Oh, a lot of people commenting. Yeah, shifts the first operand, the specified number of bits to the right. Excess bits shifted off to the right are discarded. 0 bits are shifted in from the left. The signed bit becomes 0, so the result is always non-negative. Cool. Thanks, Partha. Yeah.
So yeah, so I believe if you did a right shift of a negative number, you know, just the two greater thans, it would start shifting in ones from the left, right? Because it would preserve the sign. Yeah, there you go. Unsigned. No. Well,
Oh,
let me back up.
that's signed.
If it was a signed right shift assignment, and it was a negative number, it would start shifting in ones from the left.
Okay, so that's. Oh, interesting. I don't know. Operator
There you go. Yeah, Partha just posted the sign propagating right shift.
Cool. I'll be sure to post all these links also, because this is really good study material. Do you use these much? I mean, yeah, probably. Jay and Danielle are a lot more comfortable with the metal.
Yeah, but JavaScript's supposed to be taking you the other direction, right?
Yeah, exactly.
more abstraction, less metal.
Yeah.
As
away from this.
Coding like his own hashing algorithm for something, and maybe.
We've got to get you better internets, Danielle.
I know, right?
It always sounds so interesting, and then
Right.
his own hashing algorithms.
Like what? Yes, please continue. Oh.
Yeah. No, what did he do with
I saw one example that in the link Danielle posted is if for any reason you might be expecting just any type of number to an array index, you can use this unsigned shift something like that, and it shifts it up. It rounds it, of course, to an integer, just in case they're giving you weird, like you're getting user input and they're giving you weird numbers.
Yeah.
So.
I mean, that's kind of the whole point here. I think is where the link.
Yeah,
like
absolutely.
You can't call like a negative number on an array. It'll just give an error, right?
A -1 won't, but I think the rest of them will.
Right.
Or it'll give a undefined something. But there, even the example was 1.29, and I think lemon, the word lemon, would actually get converted to an integer of some type. Yeah. I'm not quite sure. But.
Yeah, and this is probably actually calling this internally.
Undefined.
It's probably doing like it's actually evaling the inside of this because I'm using brackets. Yeah, those are all undefined. Look at the 0. So if I try to do -2, yeah, it's getting what I expect. Cool. Yeah, so I kind of want to look at this a little more, just because this is the real reduce function. Not sure how helpful, but basically it's that we get some optional parameters. So if the length is just 2, then you don't need that start function, and the value is just the first thing. Oh, Michelle's calling me. Hey, what's up, man? Oh no, it's still on. I see you in here. Oh, okay. Yeah, just let me know if you need help. Alright, later. Sorry. Yeah, but
It's all good?
yeah. That's my friend who's doing machine learning at UTD. He's trying to learn JavaScript.
Oh, nice.
Yeah, so. Yeah, I mean, there's obviously like a lot to the reduce function, and just a plethora of ways that it can be used. A plethora. But yeah, I mean, it's still kind of like applying. It's basically doing like a map. It just has some kind of different start condition. It does some slightly different things, and it just returns one value, which could be an array.
I think it's interesting that it uses a while loop. You don't really. I was thinking it would have only for loops, but you have a while in there.
Yeah.
Okay, the lesson length.
There's a for also.
Yeah. After the while, after it does.
Mm-hmm.
All right. So actually, what is happening? What is k? I guess I'm missing all the declarations of variable. Oh, it's 0. Okay.
Yeah. Yeah. So k is like your incrementer. And then value, so yeah, basically the thing about reduce, like the first time it runs, it doesn't return anything. And then the second time, because it needs 2 elements to do anything with. So yeah. if you have an array of 1 element, it's not going to do anything. If you have an array of 2 elements, then it's just going to return the second element, which is happening right here. Otherwise, it goes into this actual reducing. So this is what's going on there.
Actually, I think that for loop runs.
That's a weird for loop. There's no initial condition on there.
Yeah.
Well, they go ahead and say k equals 0, which is what they're working with.
Mm-hmm.
Yeah, what is happening in that while loop? We have k is the incrementer, k is less than length, and k.
Not k in t.
K plus plus. What is t? T is the object. So is it just getting the length that they're working with? See, why is that a while loop? Because k is just an integer. I don't think I've ever tried. I've never used k in t or an integer in array like that. So can you run a quick check real quick, Dan, and see see if 1 is in some array of non-integers, I guess.
Can you ask me that again?
Yeah, sure. Because it says right there, it says not k and t. K is just an integer, and t is just the is it the object version of the array?
I'm not really sure.
Right. So it says var t equals object this. This is the array. So is t just an object version of the array?
I thought that this would be this might actually be window here.
Oh wow.
So it might be checking that this key isn't attached to the window. Otherwise, it could, because that's just like a Boolean, right?
Mm-hmm.
Yeah, I'm not.
But I'm wondering because it then increments k, and it'll keep going through that while loop until it's gone.
Mm-hmm.
So I wonder which one. I guess less than length might be the part that goes false then.
Yeah, because we want to compare it to length, I think. So it's like k just goes zoop, like up to this length value, and then we have a new kind of maximum that we can work with, and then yeah, that's how we're able to get this get to this error, and then otherwise, yeah, otherwise this is our new reduced value. Oh boy.
And there's t again.
Yeah.
Well, t is the array. I think it does end up being an array because it gets bit shifted over. Oh wait, I'm completely insane. Maybe. Oh my goodness.
Yeah, go back to the top. What actually gets passed in?
Just I mean, it looks like just the callback.
Oh, cool. All right, so that's this if statement as actually saying if they pass in that initial value, then use that as your starting value. If not,
Yeah.
then that else, I'm still not completely sure what's happening in the else, but TK was.
Oops. Okay, so I just overwrote the reduce, but let's see what happens if I do like and yeah, all it takes is a callback. It's really interesting. I'm gonna pull out that value though. It's 1. And several undefined. So that's this because I rewrote it so it would log the internal this, and it's undefined. Oh, probably because this is actually doesn't have a name. So I'm try. If I set that to a var, I wonder if that'll be the context. Nope.
I'm not sure if this in any way fixes or does anything, but I think the function, the callback, takes 2 parameters, period. But I don't think that's going to change anything, really.
Oh, it takes 4 arguments. Oh, you're totally right. And the array is the last.
Wow.
I just looked at this.
That's pretty cool. All right, that callback's pretty special. I like this a lot.
Yeah.
Oh, index and everything. Wow.
Yeah, and actually, so that's kind of what it's doing. I think it's like tracking the current index, the current value, and the current index.
Yeah, that's what K seems like. It definitely is.
The index
Or
of
something like
element being processed in the array starts at 0. If the initial value is provided, then index 1. And the initial value is optional. So I have mod reduce, and I'm just going to do A, B, C, D.
That's pretty cool.
And then this will work.
I think your screen froze for me, so I'm just seeing nothing.
Oops.
Are you actually typing anything?
Yeah.
That's
Oh, there we go. Yeah, okay, interesting. So this is it.
cool.
Yeah, this is what's going on. So just for reference, MA here, like for my array, is just an array of 5 elements. And so the reduce, so the first time when it's at index 0, it just returns that. Just that first index, because there's nothing before it. It doesn't have anything to do to operate on. Then the second time we're at we're on index 1, and it returns 2, and then 1, and then the array. Right? Because this isn't that third parameter the array?
Hold on a second.
So previous value. Oh, I'm sorry. I probably set up this console log weird. So this is A, B, A, B, A.
It looks like it just skips
array,
the entire
undefined.
0 index. Well, I think you're also getting unrefined because you're not undefined because you're not returning anything. So after the first time it runs, it's not working on anything because nothing got returned to it.
Yeah.
So then it doesn't have an A.
Right.
Or maybe a B. I can't really tell. I think it's A.
It's interesting.
That's pretty cool. I like how that worked out.
3, 2, and then 4, 3. Yeah, but you can see how it's reducing, how it's taking that current index, previous index, array, not returning anything. Then the next one in the array, not returning anything. Then the next one. And
absolutely. And then the final value is undefined as well.
Yeah. So can I did 0? Can I do that? Yeah. So I can reduce over 0 also. Which then it's returning that initial value first because I specified it, and then doing the reduce.
Nice. Very cool.
Yeah, I think this is reduce is definitely the most sophisticated of these, I think.
Yeah.
But yeah, I'm just gonna like, and I think like here pretty soon, if it's cool with you guys, I don't have an answer for this yet, but if we want to work through one of the assignments together for some time,
Sure.
I'd be super down to do that. Or if anyone's already answered it and just wants to show what they did, I'm also told that would be great. Just want to move on now. Oh yeah, so we had this noisy function, and it's kind of funny. So I can call it like whoops. Oh, because probably one's not defined. I don't think it's the first one.
Doesn't it noisy take a function?
Yeah, I think so.
Yeah.
I'm doing something wrong.
I think the function then takes an argument as well. So you can either.
Oh.
Let's see. Noisy takes a function that takes an argument. Also, I think you're. No, my bad.
It's not clear how many would be enough. This solution is also derive f of the information in arguments.length. Since we'd always pass along the same number of arguments, it wouldn't know how many arguments were originally given. These kinds of situation JavaScript functions can have an apply method. Yeah, so this is where we get the difference between call and apply here, where apply takes an array of arguments and evokes that function with each of them.
Whenever you do that, does it? I didn't stop and check this one. I was confused. Does it take them at the same time, or does it just run the function several different times? I guess what you were doing in the console is perfect for this.
Yeah.
And why does it take null as the first argument?
First of all, which were we passing null? Okay.
Oh, never mind. I see that now. I just didn't read that one sentence. Okay, we're good.
Oh, does it say why?
Yeah, it's used to simulate a method call. Still not entirely sure what that means, but he says they'll cover it next chapter.
Okay. That's pretty common on a lot of these. On the callback will take null as the first argument. See you later, Danielle. Thanks for coming. Sorry about your internet. Yeah, so let's see. Okay, they actually, where did they define it at? It's oh. I might have like erased this function too. Maybe that. Oh, here we go. Okay. Yeah, so we got this noisy function that's taking one parameter as a function and then returning the arguments of that function. and then logging out the argument, and then calling the original function that was passed in with the argument of the returned function, and logging that out. So you would have to, yeah, you would have to pass in some kind of define some kind of predefined values. So like this boolean.
Mm-hmm.
That's where we get, yeah, it got false. So change that. Same.
I kind of wish this one had a better implementation, because this noisy and transparent wrapper, I think, don't give it justice. Just how, not complicated, but variable this could be.
Yeah.
But I think it proves his point.
Yeah, well, what happens is, if you can go back, this is what I think there is. When we call it with the function, it immediately returns another function.
Mm-hmm.
Nothing is getting executed. For example, we can break it down. So let's say you have a function f. Let's define some other function that you have. Okay. So when you call noisy with that function, what you're getting is another function. You immediately get back another function which takes a parameter. We don't care how many parameters your function is taking that you're passing to noisy, but what you're getting is you're getting back one function with one parameter.
Just that one, yeah.
Just one parameter, because the return statement has function r. In case, what they are saying is, in case if your function f that you're passing is going to take more number of parameters, then the function that we are returning should also be returning that many number of parameters.
Mm.
The problem is we don't know. The function you are going to pass, how many parameters it's going to have, is not known. In that case, it's not going to work. This will always, your function that you're passing to noisy may take 3 parameters, but the function that I'm returning to you will always take 1 parameter. So even if you are trying to pass 3 parameters, I will pass your function only 1 parameter, the first parameter I receive.
Gotcha. Okay.
So this is not going to work. Even if you are going to add r, 1, 2, 3, 4, etc. to the function that you are returning, if tomorrow you want to increase the number of functions, then you have to go back and do this again.
Right.
Update the function that you're returning from noisy. What they're saying is the apply is going to change it. It will automatically take care of, if you're passing an array of arguments, it converts into an array and then pass that array to the function. So the function will get the array, it can process all the parameters. That's my take.
No, that made more sense than my understanding of it, so that's perfect. Definitely. Okay. Yeah, that was more eloquent than this book could have ever done.
Yeah. And that, yeah, like Vishal just said, information is lost in a sense. Will it execute with less information, or will it error? So typically, I think with a function, if there's if you give it more arguments than there are parameters in the function definition, then it'll just ignore those extra arguments, and you can pass any number of parameters in.
But with less. Let's try to run that. I think it did error. What did you get for? Yeah, that's a good question, Vishal. Whenever you ran noisy function s console log high plus, I think it's supposed to be s, right?
Oh yeah.
What happened? Like, what was your output there? When you run that function, nothing happened.
Yeah, nothing's happening.
So it looks like it just selectively ignored it. It's like, oh, we didn't. That's just JavaScripty things. I think any other language would have given you an error about it.
Yeah.
JavaScript's just like, whatever, man.
It's just kind of silently failing.
But let's add at the end of this line 10, add another another parameter by itself of 5. The number 5.
Nope.
Nothing.
I spelled noisy wrong. Nope. I kind of would it.
There's none.
The 5 should be outside the parameter.
Oh, there you go. Yeah.
And put another parameter. Within parentheses, you can put 5. You remove 5 on the comma. And outside that, open close parentheses and put 5 in it.
Oh, right. Yeah, that's the thing. Yeah. I'm actually calling that. Yeah, this is that compose. This is the composition. Yeah.
Cool. We have another question. If we pass a number 1, 2, 3, 4, 5, 6 to noisy, and arg3 integer, what'll it return? I'm not quite sure what 3 integer means.
I think it's just specifying the type.
Oh, okay.
Now within your function, right? Let's put something there. Let's have a return statement. Right now you have an empty curly brackets, right? Let's put a return statement, return some value there.
Mm-hmm.
No, not there. Within the curly bracket, yeah, there. Let's say return test.
Yeah, return test is good.
Or return. Not actually return.
Return, outside, yeah.
And it should say called with 4 got tests, is what I think, yeah.
Yeah. So you got test. Now, if you put 4, 5, to pass 2 parameters. That's what they're saying.
Oh,
so now
right.
you have a bunch of parameters here, 4, 5, 6, 7. Now it's always going to say 4. It's going to ignore 5 and 6. It's not going to do anything for that.
Right.
But if we go down to transparent wrapping with the apply function, it will catch those 5, 6. So let's run transparent wrapping. We can give it the same return test function, and then the next set of arguments 4, 5, 6.
And even though this is just an argument list, it's actually going to treat this as an array, right?
That's what I think. Yeah. Or an array like objects.
Array like object.
Oh, never mind. My bad. Yeah, it looks like it will.
I'm missing something. Oh, I got to return. No arguments. Do you guys see what I'm missing?
Console log? Oh, just return test, I guess. Function, return test.
Oh, yeah, well, okay, this doesn't have those.
Oh, yeah, that's right.
So, let's see. Actually,
I guess you could just put...
I could just console log this.
Yeah, give the function a parameter, and then return console.log test parameter. Who knows? Whatever you want to do.
So that's just returning the first one.
Oh, no. I would say in the actual function in line 8.
Oh, okay.
You can now pass that a parameter, and it'll call 4, 5, and 6
for each.
Yeah, I think so.
Okay, and then I'll... make sure that this is the right place for the log. It's only logging the first.
No, it's not going to loop. We are passing them all as a single argument, right? We are not calling this function multiple times. We are going to call this function one time. So what you can do is instead of return, just say console.log. We have returned the test, right? Change it to console.log a. See what is printed.
Oh, okay. 4. Only the first one.
Really only get back to 4. I'm on a little, I guess, a video delay, so it only console logged 4.
Yeah. And I assume I probably, yeah, so it's... So it actually is applying, but it's doing like Partha was saying, it's not really looping.
Try making the 456 into an array. Because maybe it's because right now it's kind of saying you have to pass it an array or an array-like object. So
Yeah.
maybe it really only sees that first one.
Then it's a single.
Yeah, because the whole point of using the apply was that
No.
we
So
didn't know.
we can still use the old noisy
Go ahead.
function in that case. So what Daniel was doing earlier, got your name right, I think. Yeah, that's the right way of doing it. So.
Yeah. Yeah, so it's like...
Right on. So yeah, I hate to pass it in an array, not just...
Should be undefined, yeah.
And you would think the keyword arguments would just pick up everything that's there. Hey, what's up, Jay's twin? I'm gonna call you Jay. Okay, now he's gone. There was 2 of you, Jay. Just so you know. Yeah, you'd think that the keyword arguments would take all the arguments and throw into an array. I guess that's what I was thinking would happen.
Yeah. Oh, that's interesting. So if I change that apply to call, it's actually returning the keys. It's returning that argument object. And I don't know what it's doing.
B and C aren't anything because A is all of the arguments.
Yeah. That's right. Good illustration of that difference.
Cool. I like call a lot better than apply. Because apply expects an array or an array-like object.
Yeah, there's also some times where you have to use apply when there's some context-dependent things. Because I think apply is actually applying that function with the context of the parameter.
No, you got it exactly right. So if we are doing something, right, I'm providing a generic wrapper, and I'm going to call whatever function you're going to provide. I don't know what your function is going to do, or how many parameters it's going to take. I can just provide the wrapper function, and you can do whatever implementation you want to do.
Mm-hmm.
So that's the advantage of apply.
Oh, that's cool. Yeah,
That's
so
actually
probably,
pretty cool, yeah.
Yeah. It's probably the case that a lot of library functions are doing something like that.
Doesn't spread do this as well now? Like, don't we have the spread operator that takes all the arguments given without even...
Yeah, that's basically the same.
So ES6 just start using spread, or what's the other word for it?
REST.
Rest. Spread rest. I think rest is what I'm thinking about then, and then spread actually use in the code block to access each of the elements. Something like that.
Yeah, but it's not available everywhere, so that's kind of if you're, if you're trying to run code in a place that doesn't have that, then
Apply. There you go.
Apply will always work. All right. Cool. Thank you, Partha. Cool. Okay. Yes. Okay. So now we're got some actual data here to work with on his family.
Yay.
So we get the Oatbrook family, and so JSON. We're like kind of always working with JSON, and I think these two functions, like these are two functions I've seen a whole lot, and of course I haven't worked with too much, but stringify is basically this is giving us valid JSON, and JSON's very, very strict about the format. So with stringify, you pass in an object, and it turns it into JSON. JSON form, JSON notation. There's no way to say that non-redundantly. It turns it into JSON, and then we can parse that JSON as if it were just a regular object. Right, and then we get this ancestry file we have access to now, and we can run some of these functions on it.
Mm-hmm.
So first example, of course, this is filtering. We've all kind of already talked a little bit about it, but it's I think how he defines it here is kind of the it's like a really good way of thinking about it. It's just that test. We have an array, and then we essentially, this could easily be a for each, but we're just doing a for loop. And if the array passes this test, if this test function returns true, then we push it into this kind of placeholder array and build that up for every item, and then when it's all done, when it's exhausted the length, then we return that array. So we have a new array that we can work with. So and again, this is one of those filters just on the array. It's built into the language. But by the array, I mean the array global. And so here's kind of our first test. We want to find all the people in our database where they were born after 1900 and before 1925, and we can define this once because we're iterating over it here inside of the filter. So rather than having to write a for each, like in your program, you wouldn't see this filter function at all. You would just do filter, and then give it some kind of condition. So let's try something real quick. Instead of a for loop, do we have access to for each here? We probably have array for each.
I think it's just, that's just a global function on global array, right?
Yeah, it should be if this is valid. I think it is. So
yeah, I think you just write array.forEach.
Do we need to pass test?
No, you don't need to pass test. and you go array dot for each, and the function is going to take some sort of a variable like person, something like that. And then instead of using the array I, you change that to say person.
Yeah.
But if you're going to duplicate the functionality that he already had, you've got to be able to pass in that function, like he does with test, right?
Yeah, which we're doing. So this is the same answer, right?
Yeah.
We're just logging the whole person instead of. Really, we can push a.name. Yeah.
Yeah.
So yeah, same thing, just with the for each instead of the for loop.
What is going on in this array down here? What? It's an array of objects? Is that what?
Well, here it's an array of strings.
He's got an array of objects.
I'm just talking about the output here.
Yeah.
This is just a weird way to.
Oh.
Okay, that makes sense. I guess whenever you expanded it, it got kind of crazy looking. It got rid of all the commas, and we're good.
Yeah. Well, the test function is called for each element, and its return value determines whether an element is included in the returned array. Yeah, so we can also filter for specific things. And this should. Yeah. Okay. So even though I've redefined that oh yeah, see, so here he's using that filter method, the native one. Yeah. Any questions about filter? It's really handy. I think it's kind of the first higher order function that I'd seen. It's definitely the simplest. But it is this, this is that kind of switching that I was talking about. And actually, I'll undo this and go back to the for loop. I think it's kind of a good kind of just mental exercise to think about what's happening here, like with this test. Just for like 20 seconds really quickly. Yeah, so I'm passing in that array, and then this function person. So what's the person here? That's just each item in the array. And then I'm comparing that field. And if they pass this test, yeah, I'm pushing it in. I'm returning. Pretty straightforward. Looks like that. Okay, so map. So what's the difference between map and filter?
That's a good question, Dan.
Okay.
What would your Jay?
Okay. With filter, you're just passing it a logic function, right? It's either going to return true or false. Either include this thing, or don't include it in the result, right? But if in map you're applying a transform function. It could be anything,
Right.
It's not just a true false query type thing. You can make pass in any kind of function you want.
Yeah, exactly.
That's a good answer, Jay.
Which could be a filter.
Yeah, good. I've done my good deed for the day.
Thanks, Jay. Yeah, so, but it's that same kind of structure where we have this accumulator array, and which we're returning. But this transform is being applied to the array item before it gets pushed in. And this can be anything.
Yeah, the return value in the filter, the number of elements in your array or object that you are getting back in filter may not be the same size as the array that you passed, but map will always return the same size array back.
Ooh, nice.
That's a good difference. Yeah. And I can also, instead of just console logging here, actually have this new array. That's the value of this map operation here. Whoops, console.log new array.
Yeah.
And yeah, it's the same thing. So then with this new array, then I just have another new array that I can do more functions on. So
Right. Yeah, I think that's one thing that's really good about these I guess these basic JavaScript functions, higher order functions, is that they don't alter that first array or the first object, whatever they end up getting. So that still exists too. So if you want to just do something with over 90 and still do something with new array, you could, for whatever reason, use both of them in a function somewhere. They're non-modifying.
and then I can trying to run off. Log new array. Oops. Oh, not .name. There's not. Those aren't objects. It's just that one item. Yeah. Okay. So I just pulled out that one field.
Yep.
And I can. So if I wanted to get this eventually, and for whatever reason I wanted to go through these other operations, I can. A map and filter are chainable. So I can just attach this filter function here like that, and then log, and yeah, there's that value that I wanted. And literally I can just do this forever. I can take another. I can map over this one item, and return. My name is plus item, and then yeah, and then I can I couldn't reduce that because it's only one.
You can now call toArray on it, and then do whatever you want with that, with this new string of characters or array of characters. Or what does toArray do? It might just break into words actually.
Well, can I do?
Or is it split? I think it's split. .split. Man, I get my languages mixed up. I forgot which one it is in JavaScript.
I don't know if I can do.
I think it's split.
Well, yeah, but I need to pull out that item, right? Because that's still an array, and split's on a string.
And it's toArray then.
It's toArray? Isn't it toString? Yeah, and then I can do toString split.
What was it? It was a string to begin with, right? Before you did toString? What was it before that?
It was technically an array because it was getting returned from a map, which always returns.
Ooh, nice. It was just a one character array. I like that. Okay.
Yeah. So then I can call, and then on that split I can then map that because it's still an array.
Filter. I guess the point is you can do whatever. All the filters, maps, anything.
Yeah. And I don't have. This is where you start feeling like powerful and like kind of crazy at the same time.
Mostly it's crazy at this point.
Yeah. But this is definitely like this is the powerful thing about functions to me is this like composability, and then once the next like really thing that I got to work with is those like what we were working with the noisy function and the wrappers.
Definitely. I think just thinking to use that when it comes to just writing your own stuff, just thinking to use that is just blows my mind. The use cases exist, but I would never consider that. It's not something that's just tip of my tongue vocabulary just yet. But
yeah, totally. I think it's just practice. It's just using them a bunch and having them like save you time and making your code look better. Learning to love them. So we talked about reduce quite a bit earlier. I could still look at this a little more. Here we have this reduce implemented. His implementation is take an array and then combine. I think is this. That's the kind of key, and then some kind of start. So if we kind of think of like if we're starting at 0 and our current item is 0, then we just when we return current, it's just gonna be that one thing. But turn AB. Oh, interesting.
well, when reduce is actually running, it takes what it currently has, which is usually the first part of the array, I think, and then it does something with the next character or the next element.
Yeah. So like if I could actually start in at a different place. Now it's starting at 4 before it does this add function. Or yeah, I mean this addition operation. So I can make my starting condition whatever I want. Typically it's like 0 object or array, whatever data type you're reducing into. And then we just loop through the array and set the current. So this is the reduce right here, like this line 4. This is where we're reducing the value that is derived from the application of this function on the current, and then the
like each element of the array.
Yeah, you're passing in the next element to work on.
Yeah. And the easy way of doing that is just setting it to this value. Yeah, and then I think if I look at this for like 5 more minutes, I won't like write it wrong every time.
Right. Wait, how many variables or how many parameters does this take? I always forget how many parameters reduce takes, so I just don't use it.
Yeah, you can. It's variable. You can use like. I think you can.
Right. We just looked at this, right? Yeah.
Yeah. I mean, if you're calling it as an array method, all you have to pass it is the function, the combine function.
Mm-hmm.
But it's got a bunch of other stuff that you can. That actually you
And even the function, even the combine function, yeah.
Yeah.
A lot of stuff going on there.
Totally. So super cool, and it's cool we get we get that we have access to that polyfill, so we can use like the actual implementation wherever.
And when you say polyfill, what in the world do you mean by that? Is
Okay.
that just... I'm not even going to finish that question. If you could just explain polyfill real quick.
I think it's actually like a kind of wordplay. I feel like that, like if you just took the literal definition of it, it wouldn't apply. But in this context, it means a kind of like a standard definition that will fill in that functionality in a place where it doesn't exist.
So like is that maybe like a different browser, like Internet Explorer, way back in the day kind of thing?
Yeah, and you see it all over the place. It kind of should.
The way I understand it, I'm just now trying to find out about this, but I think it's like if you wanted to add, like you said, Dan, if you wanted to add that functionality somewhere it didn't exist, like an older version of JavaScript.
Yeah.
It's the code you would have to add to give that functionality.
Cool.
Exactly. Yeah, or polyfiller, a piece of code. Yeah. It's usually just one function, but it wouldn't necessarily have to be.
That's pretty cool.
Yeah, and then there's some that overwrite prototypes, so you can make like a more powerful function with the polyfill if you want, if you needed to for some reason.
Or even if you wanted to add something to the, maybe I'm trying to think. If you want to add something to the prototype, but you didn't want to like completely overwrite it, just plug in that polyfill and change it up a little.
Yeah, and hopefully use a different namespace.
Oh yeah.
Yeah, a lot of these examples on MDN will provide a polyfill also. So this one's actually coming from the language specification. And this is that bind. So it's slicing the argument and it's binding this.
Nice.
No up. And then just like rebuilding that arguments array. Huh, I didn't know that makes sense. Cool. Okay, so the next subject is this composability thing. So, what's composability? I keep not helping.
I'll take a stab. It's like when you can apply a function on a function on a function. You know, it's just.
Mm-hmm.
I don't know. It's not a very good formal definition, but it's like you can.
I remember. Okay. Jay, are you talking?
No, I'm not talking. I'm trying to put my thoughts together here of a better way to say that.
No, I'm gonna just continue on what you were saying there. I read like the very first chapter of functional JavaScript really goes in, like the whole point of functional JavaScript is learning composability really, and it really described it as passing data along from format to format, or changing the data so that it works, so the format that it returns out of that one function can then be input into the next function. So it's really just moving the data along functions only.
Yeah.
That's all it really is. So yeah, like Jay said, just stringing functions along until the very end result is.
Yeah, sort of like a pipe almost. Like
yeah, that's just what I was about to say. It's like a pipe.
A function pipe.
I kind of get the feeling that. I don't know about this, but I kind of get the feeling that there's a little bit more to it in that you can compose like you can compose a function with another just utility function that doesn't have any parameters, and then like with that noisy, like you can with that noisy example, you can call it let's see if we have an example. Like I tend to think of it kind of like this, like function A, and then I'm like calling it with something. But then I'm also have this function B that has its own, you know, like let's say a.
I think you might need to return function B or something like that. That I can kind of see what you're saying.
Yeah, I mean this should work.
Maybe not even return. Go ahead.
Yeah, so I'm kind of like I'm calling function A with the results of calling function B on this parameter.
Do you have to return function B though, or?
No, I mean I like won't. Who knows within the pseudocode what will return.
Yeah, I think that would work too. I think especially not even just the very first example here in the sandbox.
Well, yeah, I mean,
says it has this plus function just in there as well as a utility.
Right. And I mean here we're just kind of passing in. These are really just useful shorthand because map could just take this function. But when we pass it a function as its parameter, then it's going to take P as a parameter and it's going to return this thing. And we can just write this, really nice. Like I'm going to take the average of ancestry after filtering for male, and return their age.
Yeah, but I mean, really, if you look at map age, it's getting that. It's taking the output of filter male as an argument.
Right. Yeah.
Yeah. I mean, it doesn't really show that inside the parentheses, but that's the other argument to that function.
Oh. Transform is not.
Absolutely, I think. I think that's one of the hard parts as humans reading these higher order functions is that we don't see the array that gets produced after filter gets run. So ancestry.filter is going to return an array on which map gets called, which makes sense to us because we're learning this for a reason. But I think that was the more difficult part for me when I first started learning it, was realizing just reading it doesn't make any sense, but the data is getting transformed with each of these functions. So, my 2 cents.
Yeah, I mean, and this is this is the pipeline right there. It's going from left to right, and we could keep attaching, which I usually see it called like chaining, but he's calling it compose here. We'll call it compose for now. And then we're able to do this really nice operation. Okay, let's keep going. So we have this little note here about higher order functions potentially being less efficient, mostly meaning that you have actual function, like additional functions that are being ran that are going to take up space in memory, and there's going to be some execution time rather than just doing a for loop. But in most contexts and in most browsers, the difference is so minuscule that you can usually just write the nice utility function and not worry about speed. It's going to be pretty fast. And, you know, without, like, here he's talking about big O, but he doesn't call it big O. But that's kind of what this is. Like, if you have a 4 inside of a 4, then your operation time is going to be a function of the first, you know, however many times the first one is ran times however many.
Yeah.
Times
And you could have some trivial code that runs in that innermost loop, you know, that looks innocent enough, but it's executing so many times that it eats up a lot of cycles.
Yeah. Yeah, I could totally see that happening. So here it's probably, it's probably good if we can use some, to try to use these things and compose our transforms better to try to avoid, like, in squared or in cubed operations.
I just have a suspicion that those built-in functions, like those array functions, are probably optimized a lot better than the things we would write ourselves.
Yeah.
Yeah,
like that bit shifting thing earlier.
Yeah. So I think that would be the first thing to go to, is that if there's a built-in functionality that does it, use that. Try that first.
Yeah. Cool. Are we actually okay? So this is about it as far as I actually got today. Are we? Do we have an exercise here?
This is a weird one. This is an exercise he kind of walks through, and I don't understand it. So I kind of get it. I don't like his statistics, because I just don't like statistics.
Mm-hmm.
He walks through this one, and it's pretty cool.
So
this one's recursive, where you have to walk the tree of all your ancestors. You walk through the tree of all your ancestors to find out what's the genetic contribution from one guy, where you know the name, his name, right?
Okay.
And basically, it walks through every branch, and if it doesn't find his name at the end and the contribution is 0, then there's one branch where eventually it goes, here's great-great-grandfather, or whatever his name is, and then that one returns, and it does all the divisions, going back through those recursive calls to give you what fraction it is of his ancestry.
Okay.
But I looked at it long enough to figure that out. Is that it goes through that whole ancestry tree, and there's only one branch that it cares about, and once it finds that, then it pops back through all the levels of the recursion and does the calculation.
Ah, cool.
If you go down, I believe some more, you'll see the actual answer. Not scroll down even more. This one. Never mind.
Right.
Even the one above it returns the answer. This is the one I was looking at first.
Yeah, this is a different one here that you're showing right now. This is people that live past 70.
Oh yeah, my bad. Scroll up a little bit and a little bit more. I don't like that split apart. I want all my data in the same spot, but. So what reduce ancestors does is, this is the part that actually goes and finds the tree, finds the actual branch you're caring about by returning null. Is that right, Jay? Correct me if I'm wrong, because I'm pretty sure that's right, though.
Yeah, that's what it's doing.
And that's about all I got, so...
Oh, and by name is that's defined
And
here.
then I was like, this is insane.
Oh, this is
Yeah,
the.
he defines pH as just Philibert Haverbeek.
Yeah, all
So yeah,
this.
instead of
Yeah,
looking through objects, he's just looking for a person's name.
yeah, it's
Or
just
he's looking, he can find. Go ahead, Jay.
Yeah.
You did that way better than me.
it just builds up a little lookup table, that by name thing. It's just
Yeah.
so you can look them up by name
Yeah.
instead of having to search through those objects.
Yeah. So this will be just all the names if we log this. So we make like a little table.
Yeah. Yeah, every name is a key to the object.
Yeah. That's cool. So then, yeah, we're not using it till here, or till right there. But this reduce ancestors. So it's taking that, we're taking that name, or we're taking the object whose key is this name, and if it's null, we just return null.
0. And yeah, it ends
Or
up being
return
0.
Yeah. And then if it's not null, we apply this our callback on the person, and then
Their mother and then their father.
Okay, so this is that recursive.
I put value 4. Yeah. Oh yeah, recursive. I see now. Okay.
Yeah, yeah.
And what that's doing is returning some number. So we actually the next little sandbox is saying return that mother's value and the father's value, divide that by 2 to get, I guess, some average value.
Yeah, and it has to return from mother and from father because his family tree is intertwined. Like most people, you wouldn't think you'd have a common ancestor on both sides.
Yeah.
But this guy
sometimes.
does. Yeah.
Yeah, exactly.
Yeah.
Right. And this is what that. Yeah, I guess I'm a little confused about.
Yeah, but if you look at that function shared DNA, this is key to it because that's the only way it ever stops recursing is if it sees Paul's Van Haverbeekie or whatever his name is.
Mm-hmm.
It returns 1, right? And that ends that chain of lookups. And then from there on out, it's just dividing from mother and from father by 2. But it's all based off that return of 1 from that guy.
Mm-hmm. And it's interesting that this F is taking the, okay, that makes sense. So this from mother, this is getting defined right here. And this from father is getting defined here. Person staying person, of course. And then we're taking those values and passing them in. And if their name is that name, return 1. Otherwise, then take the value from this, add them together, and half it.
Yep.
So I'm still kind of missing where this is.
Well, see, you look at that last line of reduce ancestors, console.log reduce ancestors. Then you're passing in shared DNA kind of as like a callback.
Oh yeah.
Yeah. So that shared DNA is what's F. It's F in reduce ancestors.
Oh, that's where and that's where that value is. Okay.
Yeah.
Oh, okay. Yeah, that's what I was missing where like that number was coming from. Why is that? Oh, because it's like doing the recursive thing.
This is a I thought I understood composing stuff until you got to this example. Like, I understand what's happening, even for the most part. I think it's just the example of the family tree that's kind of getting to me. Like, I don't understand why they divide by 4 at all.
Oh, because this table, he's not in the table. The guy is not in this table. His most recent
so he has
ancestor.
to account for his grandparents as well. Is that what it is?
Yeah. He has to account for people that are not in the table.
Oh. Through the magic of recursion, it can simply call itself to handle the father and mother of this person. The results, as long as the person object itself are passed to F, along with the person object itself, are passed to the callback function, which is shared DNA, which returns the actual value for this person.
Yeah. Then he says we could use this to compute the amount of DNA for my grandfather, and that's where the divide by 4 comes from.
Oh, okay, for himself, because he only has 1/4 of his grandfather's DNA.
Yeah.
He could have just made up people for the book. We don't know these people.
Yeah, really.
That's really cool, though. Just want to look at one of
yeah.
these objects a little more. Mother null. Huh. Is mother null in all these? Nope, that one isn't.
No.
Oh, I think that's a later function where we're finding the ones like without mothers. I think we're going to be working with this table quite a bit.
Yeah, it's in the examples.
Yeah.
There's at least one.
I will study up on this. I will do better next time, guys.
No, that's fine. Today has been pretty fun. I think we should... Did we ever finish Chapter 4's exercises?
I think so.
I
yeah, I
think
thought we did.
left
Yeah.
one.
Yeah.
Oh, I think we left one, like the very last one. I might be completely...
Yeah,
Maybe I
go
left.
back. Yeah, go back to 4.
The deep comparison? Oh, yeah. No, we didn't
Yeah.
do that.
Okay.
Yeah,
I had a
or the
note.
list. I don't
Yeah.
know if we did. Yeah, deep comparison.
Oh, yeah.
I have one that I claim works.
I found a nice deep merge this week, too, if you need to do that ever. Do you want to share yours, Jay? If you
Sure.
can find
Just a second. Let me get it open. See if I can. Hope I can remember how it works. But yeah, let me share it.
Let's see where. Okay, we're about to do bindings.
Okay. So let me know what you can see.
Gotcha.
Okay. So deep equal. We're passing it 2 objects, x and y, and I just assume I make the assumption that it's true that they're equal, and then the rest of the code is like figure out if they're not. So first thing to do is check, are they both objects, and you also have to check whether they're null, because if they're nulls, it does some funny things on the comparison. So, but the main part of this is just if they're both objects, then you would need to start doing the recursive call, right? And if they're not objects, you can just compare. Are they equal? So let's look at that part first. Cool. If they're not objects, then that means it's just some primitive. It's a number. It's a string, or So you just compare it there, and if they're not equal, return false. Okay. If they are objects, you want to look to see if they're the same length. Okay. If they're not the same length, they're not equal, so you can stop right there. Right.
Right.
Okay. If they are the same length, then you go through and you do a for loop for var p and x, and then let's look at every property in those objects, right? And since they're the same length, I can just pick X, and walk through every property in X, and then you have to call deep equal again, right? So that's the recursive part.
Oh, interesting. Okay. And that's going to ask.
Okay. And if it comes back, if that comes back false, if that recursive call comes back false, then we're done, right?
Yeah.
I know that it's false, and we can just bust out of this. We can bust out of this loop and return false.
Yeah.
But if it's never false, then you just end up down in return equal.
Yeah, because it's just.
Yeah. Well, actually, I made the code where it does a break where this.
Oh, there you go. Yeah.
Yeah, it always goes to this return.
Yeah. Yeah, if you didn't have that break, it would.
Yeah, it wouldn't work without the break. Yeah. I mean, you could put a return there, but I kind of like to only have one way out. Instead of having returns running amok everywhere.
Mm-hmm.
I mean, sometimes I'm kind of leaning toward doing that anymore, looking at other people's code. But for the longest, I always thought there needs to be one way in and one way out for a function, and that's kind of the way I wrote this one. But anyways, I checked it with a bunch of, things to see if it was to see if it actually worked. I tried it just with numbers. Tried it with numbers. Okay. I tried it with nulls. Tried it with not a number.
So it only works on objects.
No, it'll work on primitives too. And I tried all these cases and they work.
Oh, awesome.
Cool.
Even like with arrays, I thought, well, I really didn't know till I tried it, but I thought, what if I pass in two arrays, and if they're two arrays of the same length and different elements, then it returns false. Two arrays that are the same length and the same elements, it returns true.
That's very cool. Yeah, that seems very useful.
Yeah, I mean, you would have thought there would be a built-in for that. Seems like there ought to be.
Yeah.
I wonder if there is an ES6.
Are you searching that?
Yeah, quality comparison. Because there is like an include. Yeah, there's like string includes now, so you don't have to do the for loop thing. Oops. Recursion. Check deep equality. If there's anything shorthand. It doesn't look like it. Sets. Sets are actually a new data type.
What? Are they like lists?
Yeah, they're kind of. Yeah, they're basically like lists. But then there's also there's different kind of sets too. Look at these. Oh boy. Here we get sets. Yeah, the key is you store unique values of any type, whether primitive values or object references. So you can't have repeated values. And then it has these add, clear, delete entries for each has and values. And you ask the size of it. And then there's another kind. Oh, there's maps now, I think, too. Yeah, there's map. An object with a simple key value map, any value, both objects and primitive values may be used as either a key or value.
Huh. All
Oh,
right.
that's pretty neat.
Yeah, and you can use it with for of. It iterates its elements in insertion order. A for of loop returns an array of key value for each iteration.
Does it have a search?
Like, what are my entries say?
Yeah, I mean, I just wonder, like, if you could use it as kind of a simple database, where you just.
Yeah, I would think so. It has an iterator.
That's pretty cool.
So, yeah, so it has this entries, which is an iterator, so you can call next on it, and it'll remember the place that you're at. It has. Oh, that just returns a boolean. But that's like a quick check to see if the key's there.
Mm-hmm.
Maybe get. Yeah, get will return a value based on a key. So I think that would.
Yeah, pretty handy.
Yeah.
Yeah, you just set it like that. So that's key value that you pass in to the set method. So bars will return foo. Yeah. An undefined key returns undefined. Yeah. Yeah, that's kind of nice. And I think these are already in Chrome, and they're in the newest node. They're probably even in Node 4, I wonder. Yeah. Should be able to use this. Oh, neat. That's what it returns when you set something. Kind of weird that they reuse the arrow there. But I guess that's just it sets it to a getter function. So when you call get, if you.
Oh, I didn't. Yes, set and get. Interesting.
Mm-hmm.
Very cool.
And then I can probably do. I haven't used any. I've never made a map. So if I clear it, that's empty. And I should not be able to get that value again. Yep, no, it returns undefined. Yeah, so that's kind of cool. There probably will be small in-browser databases that are probably just layers on top of these new data types. Wouldn't surprise me. Because you would just need to build like a pretty minimal API to work with them.
Mm-hmm.
Cool. Yeah, I'm still like the symbol one. That one's really crazy. And proxies were pretty popular at one point, but they seem to have fallen out a little bit. But the symbol's kind of crazy. A symbol is a unique and immutable data type that may be used as an identifier for an object. Symbol object is an implicit object wrapper for the symbol primitive data type. And it's got these replace. It's got symbol.species.
I know Ruby has symbols, but I've never really wanted to ever learn too much about them just yet because they seem kind of odd. But yeah, they're just unique identifiers. Is that what it says?
Yeah.
Yeah, that's all it is.
It probably comes directly from Ruby. Wouldn't surprise me.
Probably. I don't know where it would have. Usually symbols are just used for keys. For any reason you need a key, or basically it's constants that you don't have to really define. In Ruby it's a little different. You don't really have to define stuff. So you would just make it so you don't say var, let, or const, anything like that.
Mm-hmm.
It's just used as usually it's a key, or if you're doing classes or anything like that. It's used as an attribute, something like that. That's not ever going to change.
That's cool. Yeah, it seems a little more like you're kind of operating directly on the data a little more. With, I don't know. I don't know much about Ruby though.
No, operating data. No, really. When I say keys, it's just if you know that this class is going to have these attributes, it's the key. So it's the variables that then get set. So name, age, height would be symbols, and then of course you have different. Each instance of the class would have different values for the age, name, and height. It's not very special. From what I can tell, it's not super special. It's a lot of words. I wouldn't think JavaScript would implement it just because just to declare things, and the word symbol is a little too long for me to want to type out every time. But there you go. Maybe it probably has more uses than I can even comprehend right now.
Yeah, I feel like most of the times I've seen it have actually been like internal, like stuff inside of the language. I think that's probably why they exposed it, because it was something that they were using inside of the core library. But I don't know much of the history of this one.
Yeah, I'm struggling with when would I want to do that. Like what what does it give me that I didn't have otherwise?
Well, nothing in Internet Explorer.
I guess you're right. Maybe try clicking on well-known symbols on the little index there, or something.
Well-known symbols. Where am I
Under
going?
properties. So under the third.
Yeah.
Built-in symbols represent internal language behaviors that were not exposed to developers in ECMA 5 and before. These symbols.
So yeah, you were right. It was an internal thing.
Well, I know that I saw that a lot. Yeah, like when I was kind of digging down into the call stack, I would see that eventually. I wasn't sure what it was. Symbol for something. This does have a search, Jay.
Yeah. It looks like all those iteration symbols are used by string.
Yeah, I think so.
Yeah, so they must have good utility for something.
I hate to even hazard a guess.
Right.
Symbol for to source returns a string containing the source of the symbol, overrides the object.prototype.toSource. And you can do toString on it too.
Yep. Okay. No idea. No idea. Maybe I could look it up in the Ruby, because I know I've seen it used very explicitly, and especially in Rails. So it might make more sense there, and then I can come back and apply that to JavaScript. I'll be back with more information, or anybody could be.
Okay, see you later.
Basically, so I actually do have to head out.
Oh, you do? Oh, okay.
Yeah.
Yeah.
So, do you mind if we? I'm not sure. Whatever. If you guys are gonna finish this, if you guys don't, do you mind if?
I need to cut out pretty soon too. Next 10 minutes or so. So maybe we could finish it up next session.
Yeah. Let's do that.
Partha did just post a in-depth symbols blog.
Oh, nice. Yeah. Oh, yeah. I forgot.
Definitely not the same thing as symbols.
There's actually, like, this is valid now. Oh, no. It's, well, probably can't do an operation on it, but I can do, like, oh, no, it's unexpected. I should read the article before I just start typing stuff. because there is some well, maybe not in the browser, but you can do this like in the shell. These are valid characters because they have like Unicode values.
Oh yeah.
You can just use them directly. The 7th type. Cool. Well, yeah. Yeah, sorry I wasn't more prepared this time, but I always get a lot out of this, and I just kind of want to thank you guys for like continuing to participate. I have every intention to finish this book, even if it takes a year or whatever.
It'll literally take a year, given the schedule and the number of chapters.
Yeah. Yeah, and that's cool with me.
Yeah.
Yeah, that's okay for me too. Because I mean, each one of these chapters deserves some time given to it. And it's not something you can just skim over.
Yeah, I think being on schedule with other people makes you want to actually finish it and whatnot.
Yeah, and me too. Because if it was just me, I know I'd end up blowing it off. It's just like everything else, If
Look, I can read that chapter some other time. I'll get it.
Yeah.
Yeah, it's always kind of cool the stuff that I accidentally learned too.
Oh yeah, especially just coming in here. What do we get? Bitwise operators.
Oh yeah.
Yeah, bitwise operators, symbols.
I'm going to take up a little collection to get Danielle better internet.
Definitely fun working with everybody here. And
yeah. Yeah, cool. Okay, well, yeah, let's call it and do this again in 2 weeks. And
did we say we were going to do the examples next time? I just missed it.
Yeah, let's try to do those first. I'll probably work on them in the next couple of days or this weekend, and or maybe we can even look at it a little bit at Node School. But I'll try to be up through the next chapter's exercises next week. That'll be my goal, and then we'll just set aside some time.
Next chapter's not quite as dense. Like this, the example he used here was kind of.
Yeah. Yeah, it's pretty complex. I mean, we're getting into a lot of the composition and binding. And
no, I just mean like the genetic theory. Like I didn't like the numbers he was using. Then dividing by 4 all crazy. I didn't.
That's my one criticism of this book is it's easy to get off in the weeds just in the example.
Yeah.
I guess what I'll call the storyline of the example. So he picks out some fairly complex things. That's good in a way, but it gets in the way sometimes.
It's just another thing to learn that's not JavaScript.
Yeah.
Yeah.
Yeah, I've gone back and looked at previous chapters, like thought, what did I really need to get away from this? What's the takeaway for this chapter? And it wasn't so much about what was in the example, kind of added some extra complexity to it,
Yeah.
And I think what he's trying to do is make it complex enough that you have to analyze the code. You can't just blow through it.
Yeah, totally.
Yeah.
Like I really wish there was a little bit of an illustration sometimes, but having to it probably is good that it makes me kind of stare and dart my eyes between functions repetitively to figure out what's happening. But it would be nice if there was like an Eloquent JavaScript for kids also. Start with that. With told by a were squirrel, of course.
Yeah. Well, I was going to go off and look for my first book of symbols.
Yeah. There you go.
Symbols for dum-dums.
Yeah.
Symbols for dum-dums. All right.
Yeah.
All right. I'll see you guys in 2 weeks. I see 3. I don't know if Partha and Vishal can come up to Denton for Node School. I guess I'll see you guys in Node School before the next Eloquent JavaScript.
Yeah, I'll
So-
see you there.
Okay, guys. Well,
Goodbye.
I'm going to drop off. Bye-bye.
All right. Bye, Jake.
Okay. Thanks a lot. That was a good session.
Yeah, thanks a lot, Partha. It's a really helpful insight.
See you in a couple of weeks.
Okay. See ya.
Bye. Good night.
Night. I'm gonna save these.